index, negative radicand. So again, for instance, this problem looks so easy. The square root of -9. But what number is this really? It's a 2, which is even. Think about it. You want to say -3. Is -3 times -3 equal -9? No. So when you have an even amount of these negative signs, your answer is never going to come out negative, so that's the problem. So no solution. So I'll give you 2 problems real quick to make sure you understand this. One of them's possible, one of them's not. Here we go. I'm trying to think of one I haven't already used. I think that's right. Anybody know the square root of -25? Or the third root of -343? Well, the square root of -25 is actually, there's not an answer. And I need to emphasize no real answer, because later on you learn about some numbers that are called imaginary that work. But these numbers that we know about don't work. Remember, that's a 2, which is even, and that's negative, and that's no good. Now this one, unless I've done my math bad, and I don't have my calculator in front of me, but I believe if you put in -7, -7 times -7 is 49. 49 times -7 is -343. So this problem does have an answer. -7 is the third root of -343. So -25 has no second root that we can find. -343 has a third root. It is -7. Okay. The last part of the notes deals with this. There's another way to write this problem. We just talked about that this is an index number, and this is a radicand, and this is a radical symbol. But we can also write this as something called a rational exponent. Very easy to do, but at first it's a little weird. I want to remind you that the word rational has the word ratio in it, which means we're going to do a fraction. But we're going to do a fraction for our exponent. So for example, the third root of 8 can be rewritten as 8 to the 1/3 power. The square root of 25 can be written as 25 to the 1/2 power. Now, we're not solving it. We're turning a radical into something that is considered a rational exponent. I'll give you another one. See if you can catch on here. The fourth root, this time we'll do a variable. We've been doing numbers the whole time. The fourth root of y is y to the 1/4 power. So what's going on here? Some of you have probably figured it out. But just to make sure we're on the same page, your radicand becomes your base. Your index number, that's not a hashtag, that's a number, becomes the denominator of your exponent. And your numerator will be 1, except in in special cases that I'll show you very soon today. So your radicand becomes your base, your index number becomes the denominator of your exponent, your numerator of your exponent will be 1 unless there's a different number that I'm about to show you. But let's practice. The fifth root of j. Having trouble. Fifth root of j. And let's do square root of 20. And let's do seventh root of, we'll make it real fun, xy. Those are all radicals. If I want to turn them into rational exponents, well, j would be my base for this one because that was my radicand. I know I'm going to make a fractional exponent. 5 would be the denominator. 1 becomes the numerator. Square root of 20, what would be my base? It'd be 20. What's the index number? It's hidden. It's understood. It's 2. So this would be 20 to the 1/2 power. And then what about when there's 2 things under there? Well, you just take them separate. Or I guess if you were showing off, you could do something like that. Got it? Radicand becomes the base. Index number becomes the denominator. Numerator is 1 unless... What does that say to do? It says to take the third root of a to the 2nd power. Well, your base is just the variable a. We know the index number, 3. But we got this extra exponent inside the radical attached to the radicand. And all it does is make it where we're not going to use a 2 anymore. We're going to use a 1. Sorry, I said that backwards. We're not going to use a 1 anymore. We're going to use a 2. So here's an example. 5th root of b to the 4th is, if I want to rewrite it, and remember what we're doing, this is a radical, this is rational. It's the same thing, just different ways of writing it. You can even do it with a number. 4th root of 8 squared can be rewritten as base 8, denominator 4, numerator 2. And some of you are going, oh, but that's not reduced. You're right. You are going to reduce it. And so the last thing that happens, and I know this video has been long, but you guys know I like to teach anyway, is you have to remember the rules we taught you in Notes 15 and use them with rational exponents. For instance, if I give you j to the 1/3 times j to the 1/3, what should you do? Let's do a quick reminder. What's x times x? X to the 2nd. How'd you get that? Understood 1, and I added them together. The way Miss McClanahan always did it is she put parentheses there to show you what was going on. So back to my problem. Do you know how to add 1/3 and 1/3? I think you do. Keep the denominator, add the numerators. Answer is j to the 2/3. And then I could even show off and say, I know what that is as a radical. If someone asked me, I can reverse what I was doing earlier. That means the third root of j squared. What if you had x to the 7/9 divided by x to the 2/3? How do we do that problem? Well, going back to notes 15, let's say we had y to the 8th over y to the 4th. What's the answer to that? You learned it was y to the 4th. Because what did you really do? You took those exponents and the shortcut. This is how Miss McClanahan would have written it. She would have reminded you were subtracting. So you kept that base and you subtracted those exponents. So the problem here is we've got fractions with different denominators, and we have to have common denominator. So you would probably need to keep the 7/9. What can we rewrite 2/3 as? You multiply top and bottom by 3, that's actually 6/9. And now we can subtract. And the answer to our problem is x to the 1/9. Good stuff, good stuff. What if you had the square root of w times the 4th root of w? Coach, I don't know how to do that. Well, I bet you actually do. What's the square root of w? That. Understood 2, understood 1. What's the 4th root of w? That. What do you do when you're multiplying? Well, I actually add my exponents. If I'm going to add them, better have a common denominator. Awesome. But coach, the original problem was radicals. You gave me a rational exponent. Okay. Final answer. Right there. W to the 3/4 is the same as 4th root of w to the 3rd. Awesome. Last problem of the day. I know you're ready. C to the 1/4 and D to the 1/3 are going to be raised to the 1. Now let's do it 2/5 power. Whoa. Well, what was the rule about when you're raising a base up to another power? So C to the 1/4 needs to be raised to the 2/5. And D to the 1/3 needs to be raised to 2/5. Well, the first thing you need to know is you don't have to look at this all at once. You can do it like this. You can separate it. C to the 1/4 is being raised to 2/5. D to the 1/3 is being raised to 2/5. But the question is, do you remember how that works? So let's do an aside. Old problem from notes 15. Power raised to a power. Do you remember what you did? You actually multiplied. Why? Because x to the 4th to the 3rd power is just x to the 4th, x to the 4th, and x to the 4th again. So the shortcut is to multiply. So bringing back our problem, how do you multiply fractions? Good news is you don't need a common denominator. You multiply numerators like 1 times 2 is 2, 4 times 5 is 20. You multiply numerators. 1 times 2 is 2, 3 times 5 is 15. Is that a good answer? Almost. 2/20 is really 1/10. struggles.